Let's look at if statements involving lots of chain if and else. In this example, on the left side, you have a classical grading system. If a student score is greater than or equal to 90, print A. Otherwise, if the score is less than 90, but greater than or equal to 80, print out B. So you have this cascade if and else chained together that way. And because there's only one statement, following each Boolean expression, you do not need parentheses. The problem is you'll have these tabs or indicated spaces to help you visualize where each Boolean expression is associated with whichever system out. This is a little bit challenging to look at because sometimes if you screwed up on the indentation, your entire code is going to be unreadable. This is equivalent to the right hand side by adding an else if combo. Instead of saying if else and using this cascade fashion, you can say if score is above 90 or equal to it, print out A. If this does not satisfy, that means the score is less than 90. But if the score is greater than or equal to 80, while it is less than 90, print out B. Same thing, but if the score is greater than or equal to 70, but less than 80, print out C, so on and so forth. The right-hand side format is much better for the sake of readability and debuggability. Let's look at the decision tree for this type of chains. We can represent the previous example with this decision tree, starting with the score being above or equal to 90. If true, grade is A. If false, it goes into this decision tree. And if the condition for this decision branch is true, the grade is B. Else, it goes into the next one. As you can see, the entire problem space is this much. This represents 100% of the space. You can visualize this entire 100% as a piece of pie. So since you have A, B, C, D, F, a total of 5 different grades, this entire pie is split in 5 or 20% each, where A is here, B is here, C, D, F. And with the very last pie, you want to make use else. This will be your concluding chain statement to conclude the entire conditional. Let's look at this example another way. Let's say our input score is 70.0. Your entire flow of control starts from the top and flows through the bottom, one line at a time, starting with if score greater than or equal to 90. Since the score is 70.0, this entire Boolean expression is evaluated to false. Given that this is false, it will bypass this entire system out print line, lending your flow of control to the very next conditional. At this point, the condition is still false because your score is obviously not greater than or equal to 80. Again, your flow of control bypasses this and jumping to the next one, checking to see if the score is actually greater than or equal to 70. Now, the condition is evaluated true because score 70 is exactly what this condition is looking for. Therefore, your flow of control goes into the very next line to print out this letter C. Now, because your entire flow of control is already in this block, and remember, this is a conditional statement, meaning once this condition is evaluated, your flow of control is not going to evaluate this and also this. Basically, you can think of an invisible return, lending your flow of control to be on the very next line past this entire block of if and else at this point. Let's look at another example. For the sake of simplicity, let's just say there's only one statement to evaluate for each of the Boolean expression, starting with 3 variables, I, j, and k. The very first line of if check to see if I is greater than j. If so, it goes into the very next line, which evaluates whether I is greater than k. So this is a nested conditional. If this is true, then the inner if is going to be evaluated. This entire conditional seems rather complicated. Let's look at its equivalent. Let's rearrange this else to make your code a lot easier to understand. Basically, if you look at this indentation versus that, both serve the same purpose. However, the right-hand side is a lot more logically pleasing to comprehend than the left-hand side logic. So sometimes there are best practices. You do not want to create complicated syntax. Even though both constructs may yield the same result, the best practice mandate that the easier to read, easier to debug version trumps the other. Let's look at another example. Remember the previous examples had the inner nested if and else to bind both A and B. This version separates the A and B logic, where A falls within the inner nested portion of it, and B to be a part of the outer if condition. And the trick is to include this curly braces. This will group your entire nested statement within the same scope. Therefore, the positioning of these curly braces and how you structure your nested if and else plays a very important role in guiding your logic. We'll look at some of the mistakes or common errors developers make in conditional statement in the next video.